All right, so as I told you, I was going to interrupt you, and we're going to talk a little bit about completing the square. Okay, I just want to preview what we're going to be talking about tomorrow. So let's go to work. First, before I can talk about completing the square, I got to remind you of this. I have two lovely quadratics up here on the board. I'm going to take the first one and I'm going to factor it really quickly. But before I even factor it, I want you to notice here and here, numbers 1 and 9. Are those numbers special? Yes, they're perfect squares. Matter of fact, if I were to factor this one, I would end up factoring it, split and sign, x factors a 9, 1 and 9, 3 and 3, come together to give me a 6, 3 and 3, plus 3, plus 3. So this really means x plus 3 quantity squared. Hey, this thing is called a perfect square trinomial. Notice that I saw the perfect squares on the end. Yes? Look here. Look at this next one I'm going to do. 4 and 25. 4 and 25. Perfect squares. Perfect squares. Matter of fact, I'm going to just jump ahead. I'm going to tell you that I should be able to factor this one, or I can factor this one to be 2x plus 5 quantity squared. Now, next week, I'll go into how I was able to do that so fast, okay, and hopefully get you there to where you can do that. But that is also a perfect square trinomial. There are two that you should be able to identify by the time we're done, and that's the difference of squares. We've talked about that one, yes. Two perfect squares separated by a minus sign, and then this one, which is a perfect square trinomial. The biggest thing you want to see is when there's a perfect square at the front and the end, boom, that thing shot like an alarm should be going off in your head. There's something special about this one, or there may be something special about this. Okay, so if or when we can factor things that quickly, we end up with perfect square trinomials. Well, that's cool because this next method that we're going to learn, called completing the square, uses that knowledge. So let's say I have x squared plus 4x plus 5. Okay, now, that's not a perfect square trinomial. I know it because right there on the end, that 5 is not a perfect square. Okay, but what I'm going to teach you tomorrow is what we call completing the square. Now, this thing is equal to 0 or y or f of x. Okay, and here's what we do. We start by moving the 5 over just a little bit. We just leave a space and we put that 5 over there. Okay, and then we think to ourselves, this middle number, this 4, take it and divide it by 2. What's 4 divided by 2? And then we square it. Okay, we square it. What is it? Sorry. What's 2 squared? 4. And we're going to add it, plus 4, and subtract it. Do what? Well, if I gave you $20 and I took $20 from you, what did I really give you? Nothing. If I add 4 and subtract 4, what am I really doing? Nothing. I can do that, right? I can do nothing. Yeah, I'm pretty good at it. Now watch this. If I put a parenthesis around right here, this thing in the middle now is a perfect square trinomial, which tomorrow we're going to talk about how I can then factor that to be x plus 2 quantity squared. Yes? Now this stuff on the outside, can I add those two constants together? Negative 4 plus 5, that's a 1, right? So 0 equals x plus 2 squared plus the 1. Now, before you go like, okay, what was the point of that? Who can tell me what form that one's in? What form is that in that we just made? Vertex form. Who can tell me what the vertex of that thing is? Negative 2, 1. Completing the square is manipulating an equation or a quadratic to vertex form. And we liked vertex form, didn't we? It was really easy to graph and find the vertex. That is what I'm going to teach you tomorrow. Can I get a woot woot? Have a great day.